This is the PS linear mod sums. When they say mod function is lesser than or equal to 4 till 0, then it will also be greater than or equal to minus 4. So 2x is going to be greater than or equal to minus 4, lesser than or equal to plus 4. So doing this inequality, at 2x is greater than or equal to minus 4, x is greater than or equal to minus 2. Yeah, and doing this inequality, 2x is less than or equal to 4, x is less than or equal to plus 2. So putting it on the number line. Okay, x is greater than or equal to plus 2, x is lesser than or equal to minus 2 shows that the answer will be minus 2 to plus 2, x is an element of. Let's go to next sum. The second question is mod of x minus 2 is lesser than or equal to 3, and you know when something is lesser than or equal to 3 in mod, it can also be greater than or equal to minus 3. So x minus 2 is greater than or equal to minus 3 and lesser than or equal to plus 3. Taking this inequality and solving. So when I'm writing x minus 2 is greater than or equal to, carefully write minus 3. X is greater than or equal to minus 1. Done. And this x minus 2 is lesser than or equal to plus 3. X is lesser than or equal to plus 5. So putting it in the number line, this is minus 1 and this is plus 5. And x is lesser than or equal to plus 5, greater than or equal to minus 1. So minus 1 to plus 5, both of them inclusive, x is an element of. So let's go to next sum. The third question is mod of 3 minus 4x is greater than or equal to 9. When something is greater than or equal to 9, it should also be lesser than or equal to minus 9. Now 3 minus 4x is lesser than or equal to minus 9 or greater than or equal to plus 9. Solving these inequalities, you get, when I'm writing, I should write carefully. I'm bringing 3 minus 4x is lesser than or equal to minus 9. Minus 4x is lesser than or equal to minus 12. Multiplying both sides negative sign. 4x, the symbol has to change. So it's plus 12. X is greater than or equal to 3. Okay, so let's go to next slide. 3 minus 4x is greater than or equal to 9. Minus 4x is greater than or equal to 6. So multiplying both sides with negative sign, 4x is lesser than or equal to minus 6, x is lesser than or equal to minus 6 by 4, x is lesser than or equal to minus 3 by 2. Putting them on the number line, a minus 3 by 2 here and a 3 here. X is greater than or equal to plus 3, x is lesser than or equal to minus 3 by 2. You just write whatever is the solution that you get. Okay, close interval, open interval union, 3 to infinity in this. Let's go to next sum. Next sum is this one, is it? Which is the fourth question. So you know that mod of x minus 2 is, this is the question, like this. So whenever you have it.
Second. This is what?
Yeah, one is.
Oh yeah.
Yeah.
Okay.
So this is the question. So in this, you can simply take this and do it into two inequalities. One is lesser than or equal to mod of x minus 2, and x minus 2 is lesser than or equal to 3. So when I write it, you know, mod of x minus 2 has to be greater than or equal to 1. When as in this interchanging, so when mod is greater than or equal to 1, it has to be lesser than or equal to minus 1. So x minus 2 is going to be greater than or equal to plus 1, which is on the right side of the number line. This has got to be lesser than or equal to minus 1. So taking these inequalities and writing this here, x minus 2 is lesser than or equal to minus 1, x is lesser than or equal to minus 1 plus 2, which is plus 1. Taking this inequality, x minus 2 is greater than or equal to 1, x is greater than or equal to 3. And putting it on the number line, you have 1 and 3, x is greater than or equal to, no, x is lesser than or equal to 1, x is greater than or equal to 3. I'm getting answer like this, let's okay. So here again, I have, you know, it's lesser than or equal to 3. When something is lesser than or equal to 3, it will be till 0, so greater than or equal to minus 3. So x minus 2 will be greater than or equal to minus 3 and lesser than or equal to plus 3. Okay, so then take this inequality and this inequality. So x minus 2 is greater than or equal to minus 3. So x is greater than or equal to minus 3 plus 2 is minus 1. X minus 2 is lesser than or equal to 3, x is lesser than or equal to 5. So putting this on the number line, you know there's a minus 1 and a 5. X is lesser than or equal to 5, x is greater than or equal to minus 1. So I have an intersection part in this. So if I'm going to do a combined graph for this, let's see if I'm going to do a combined graph for this. So I'll have a minus 1, I'll have a plus 1, I have a plus, what is this? This is plus 3, isn't it? Plus 3 and I'll have a 5. I'm going to do a combined graph. I'll do the right hand side graph in black color. So it's minus 1 greater and plus 5 is lesser. I'm done it. Then so let's do this left side graph in some other color. So you know the some of the colors, let me take it as purple color, and it's greater than or equal to 3 and lesser than or equal to 1. So where is everything intersecting? You see this one and this one. So it's minus 1 to plus 1. Both of them inclusive. till union of 3 to 5, both of them inclusive, and that's your x is an element of. I hope you understood. Let's go to the next question. The next question is the fifth question. Is mod of x plus 1 plus mod of x is greater than 3? See, when such sum comes, when there is addition of two mod functions, I will always prefer to redefine the function. I cannot do it as simple as this. There's only single function, so I could do it like that. But here there are two different functions, so I need to redefine. For redefining of the function, you need to know the critical points. The critical points, how do you find the critical points? You draw this graph. This is graph. -1, this function will become 0. This function will become 0 at x is equal to 0, mod x. Equated to 0 and c, x is equal to -1. So these are your critical points. So critical points, x is equal to -1 and x is equal to 0. Put it on the number line, a -1 and a 0. Now I am taking a different color pen and giving an example, -2, a -half and a 1. And I am going to substitute these examples in these functions without considering mod and see if it's negative or positive. When I put -2, the first one becomes negative. The second one also becomes negative. So minus x minus 1 minus x, which is -2x minus 1 is a function when it's less than -1. For this, so now you can ignore this example and all. You give an example to determine whether it's positive or negative or what is the new functions happening. So minus half, you substitute minus half here, positive, minus half negative, positive and negative, positive and negative, x and x get cancelled. The answer f of x itself is becoming 1, correct? So ignore, you don't have to worry about this minus half and all. It's just an example. You get the answer as 1. So let's give 1. When you put 1 here, it's positive, positive, both of them positive, x plus 1 plus x, 2x plus 1. So I've got a new function, f of x is 2x plus 1 greater than 0. You have to redefine it like this. And for now, the whole thing, this whole thing is in a condition x is lesser than -1. For this whole function is become -2x minus 1, which is going to be greater than 3. So now -2x is greater than 4. So multiplying both sides with negative sign, a 2x is lesser than -4. X is lesser than -2. X is lesser than -2. So then therefore I found this answer. Let's go to this. Here the redefined function itself has become 1. Imagine putting it in this function. 1 is greater than 3. False. No solution in this region. Ignore. You understood? So now for this it's 2x plus 1 for this one, for this interval. For this interval it's 2x plus 1, and you know 2x plus 1 is greater than, for this is a condition. When x is greater than 0's condition. 2x plus 1 is greater than 3, 2x is greater than 2, x is greater than 1. So thus you put it in the number line, you get a -2 and a plus 1, and x is lesser than 1. X is also lesser than -2. So let me see, this is 2x plus 1 is greater than 3, 2x is greater than 2, x is greater than, I forgot, x is greater than 1. So then therefore this graph is greater than 1. This graph is lesser than -2. So minus infinity till -2. I'm putting an open bracket and I have to check whether it should be closed bracket or open bracket. See, when this becomes -1, take the function, put here -1 plus 1 plus, this becomes 0. This is -1, which will become plus 1 and eventually this becomes 0, and this will be 1 totally and still be less, it will be greater than 3, it's not. So am I allowed to include 1? Am I allowed to include, the question is, am I allowed to include 1 and 2? I have not included 1 and 2, right? So you're not allowed to, because we put 1 and 2, it is not getting a value which is greater than 3, getting a value which is lesser than 3. Therefore, I am not allowed to include. How do you check whether to include -2 and +1? Just put it there. And you know that you can't include. So this is your answer. Union of it. Are you clear? So can I go to the next question? The next question is, so the redefining part is very critical here. That comes in even in relations and functions, in functions part. So let's go to 6th question. Mod of x minus 1 is lesser than or equal to 5 and mod x is greater than or equal to 2. They've given two conditions, okay? So for this, you study for this and study for that separately. So you do it normally, no need to redefine the functions and all. So you write, this is lesser than 5 means it will be greater than or equal to minus 5. So x minus 1 is less than or equal to 5. It will also be greater than or equal to minus 5. Taking this and this separately, you know x minus 1 is greater than or equal to minus 5, x is greater than or equal to minus 4. For this, x minus 1 is less than or equal to 5, x is less than or equal to 6. So let's try to draw this. Okay, we'll come to this. Mod x is greater than or equal to 2. Is it next one? Yeah, which means, you know, it's greater than or equal to 2. It will also be lesser than or equal to minus 2. So x is greater than or equal to 2 or lesser than or equal to minus 2. Correct? So then you have to draw a graph for this, and let's do a combined graph. Let's not waste time now. Now that we understood, we're going to combine the graphs. Let's do this in one color, this in one color. So you know that x is lesser than or equal to minus 2 and x is greater than or equal to 2. From this you went for that, correct? So it's fine. So we're going to do this in different color. So let's do it in this right side in purple color. Let's write the numbers first. Let me write all the numbers. You have a minus 4, you have a minus 2, you have a 2 and you have a 6. And we're going to do the left side, the right side ones in purple color. X is lesser than or equal to 2. Greater than or equal to plus 2 also, huh?
Yeah.
Plus 2, no? Here, sorry. Correct? So this is the right hand side graph. Left hand side, let me use a different pen and do it. Okay, so left hand side, let me use the green color. X is lesser than or equal, greater than or equal to minus 4. X is lesser than or equal to plus 6, correct? Yeah? Correct, I have drawn this graph. So if you see, I know what is intersecting for the green color, what is intersecting for the purple color. I have to find the common intersection. Let's see what is commonly intersecting. All colors are coming between minus 4 and minus 2 and between 2 and 6. So in one shot I finished. I didn't do two different graphs. I just put one graph different colors and I'm finding x is an element of minus 4 to minus 2 union 2 to 6, both of them close bracket. Are you clear? Let's go to 7th question. The 7th question is it's very complicated. Mod of x minus 2 plus 1 by mod of x minus 2 minus 1 minus 1 minus 2. This is lesser than or equal to 0. So this is the question. Okay, so when they give you such question, it's very complicated for me. So what I do, I know this has to be negative, right? So what I'll do is, let's call this y is equal to mod of x minus 2 for simplification. So then you know y minus 1 by y minus 2 has to be lesser than or equal to 0. So what do you know? If this has to be negative, you know that and also lesser than or equal to 0 means always negative value or 0, correct? The numerator can be 0, which means y can be equal to 1 is allowed. Correct? And you know denominator cannot be 0 because it will become infinity. These are the two conditions we already know. You know y can be equal to 1, but y cannot be equal to 2. This is a necessary condition because denominator cannot be 0, numerator can be 0. But if this is less than 0, means this has to be negative. For this function to be negative, you can consider various cases where the numerator is negative, denominator is positive. Denominator is negative, numerator is positive. So that's when it will be negative, otherwise it will not be negative. So it's numerator negative and denominator positive. I'm going to analyze for that condition, okay? This is the method I taught you. This is the method I taught you. Either numerator negative, denominator positive, or numerator positive, denominator negative. I am not going to use that method. I'm going to teach you another very, very easy method now. When such sum comes, I'm going to teach you such an easy method, okay? So find the critical points. Critical points is y is equal to 1 and y is equal to 2. But you know y cannot be 2. But critical point is 2. So you put it on the number line 1. Y can be 1. Y cannot be 2, but still mark 2 and put a round here because you're not going to check at 2. Before 2, after 2, and what? Before 1, after 1. So let's give one example here. As you know, let's give one example as usual. An example is 0. An example is 3 by 2. An example is 4. putting this here, a 0 minus 1, negative, correct?
Yes.
And the 0 minus 2 is also negative. It is going to fetch you a positive answer. This is lesser than or equal to 0. You don't want a positive answer, so this side is false. Let's go next. Put a 3 by 2 here. 3 by 2 minus 1, positive. 3 by 2 minus 2, negative. Numerator is positive, denominator is negative. So it is true. Let's take this example, 4. Numerator is also positive, denominator is also positive, which is again false. So the only interval that satisfies this whole condition is only from 1 to 2. Correct? So you know that the interval has to lie between 1 inclusive but 2 not inclusive. Because I put 2 is always never inclusive. So this function, what have I found now? I found from this, I'm finding positive, negative, and I've got this value, which is actually y. I'm redefining y. So y actually is lesser than or equal to 1, greater than or equal to 1, lesser than 2. This is what I get. But it can be 1. It can be 1. Because numerator can be also 0. If they give less than 0, there's a problem. Have they given less than 0, greater than, equal to 0? So fine. What I've written only is here is correct. So you know what is y? Y itself is mod of x minus 2. Now bring it here. Mod of x minus 2 therefore has to lie between this and this. Now it's become a normal sum. You take this inequality and this inequality. So let's write mod of x minus 2 is greater than or equal to 1. Correct? Simple correct? And a mod of x minus 2 is lesser than 2. You know when it's greater than or equal to 1, it can also be lesser than or equal to minus 1. So x minus 2 is greater than or equal to 1 or lesser than or equal to minus 1. Taking this inequality, you write x minus 2 is lesser than or equal to minus 1. X is lesser than or equal to plus 1. X minus 2 is greater than or equal to 1. X is greater than or equal to plus 3. So you get this, and then we'll do a combined graph. We'll not do separately. Okay, let's come here. This is lesser than or equal to 2. It will be greater than or equal to minus 2 also. So therefore x minus 2 is lesser than 2. No equal to. So greater than minus 2 also. Taking this inequality and solving. X minus 2 is greater than minus 2. X is greater than 0. X minus 2 is lesser than 2. X is lesser than 4. Now I'm going to do a graph. Let me do a combined graph now. I'm going to change the colors and write anyway. So I have a 0, I have a plus 1, I have a plus 3, I have a plus 4. Let me write the right hand side graphs in green color. X is greater than 0. X is lesser than 4. Done. Let me do the other one in purple color. X is greater than or equal to plus 1. X is greater than or equal to plus 3. Lesser than or equal to plus 1. Sorry. Lesser than or equal to plus 1. X is lesser than or equal to plus 1. X is greater than or equal to plus 3. So I am doing all these graphs and seeing what is intersecting. In my opinion, it is intersecting between 0 and 1 and 3 and 4, and that should be your final answer. So x is an element of, can I include 0? Yes, I am always allowed to include 0 because first itself I told you it's possible for the answer to be 0. So I can include 0. Can I include 1? What I can't include, I have written first itself. What this I didn't write, is it? Okay. X cannot be 0 because denominator will become 0. You should know in this sum x cannot be also 0. Therefore, I can't include a 0 because I thought I can include a 0. But you know that if this becomes 0, 2 minus 2 will become 0, denominator will become 0. So I cannot include a 0 also. So can you see, even though my solution fetched me an answer which is, but when I try to verify it with a question, I am unable to include a 0. Correct? So my final answer is x is an element of open bracket 0. Can I include a 1? Can I include a 1? Yeah. Numerator can become 0. So I can include a 1. 1 is the close bracket union. 3, 4, including a 3 and including a 4. Is it justified to include a 3 and a 4? Yeah. So just make sure that you're verifying it with the given question and see if your answer is right. I'm not supposed to include 4 also. Why I'm not supposed to include 4? Because x is less than 4. But here x is greater than 3 is coming, no? But it has to satisfy all conditions. When it has to satisfy all condition. Here itself I have a condition x is greater than 0, which doesn't include a 0. Here itself I have a condition where x is less than 4, which doesn't include a 4. That itself confirms that even one thing doesn't include, I have to put only not inclusive. Now my answer is perfect. Are you clear? So let's go to next question. So in this sum I had a different approach. Of course it had a redefining. But I didn't redefine and find a value. I just gave justice as to whether it's positives or negatives and see which interval satisfies. And then proceeded. A different, very different sum. Very, very different sum. But for Shankara or PSC, no other school will ask this question. It's only kind of JE question. So let's go to next question. Is the 7th sum. So no need to draw different graphs. We'll just combine one graph and draw from now. Solve 1 minus mod of x minus 3 is lesser than or equal to half. So they've given like this, okay. So therefore I can reciprocal it and the symbol will change. So I can write mod of x minus 3 is greater than or equal to 2. Do you know I can write like this? I can simply reciprocal and write like this. Mod of x minus 3 is greater than or equal to 2. The symbol has been changed. This is simple thing. You just reciprocal and write. I'll see if I'm getting an answer. Otherwise I'll do another method. Okay, this is one method that strikes me. And I'm going to take this to the other side. Mod x therefore is greater than or equal to 5. If mod x is greater than or equal to 5, it will also be lesser than or equal to minus 5. So x is greater than or equal to plus 5. X will be lesser than or equal to minus 5. So putting it in the number line and writing minus 5 here plus 5 here, x is lesser than or equal to minus 5, x is greater than or equal to plus 5, I am getting an answer. Is there 2 equations or just one equation only? Only one equation, no? What is the final answer for this? Something else is the answer, sir. So look at what I've done. I've done something wrong in this sum because I'm not getting the right answer. So I just reciprocaled. For me, if I reciprocal, I can write the interchange symbol. So I wrote mod x is greater than or equal to 5. Mod x is greater than or equal to 5. X is greater than or equal to 5. X is lesser than or equal to minus 5. And I got this diagram. And I don't think there is anything wrong with this. However, keep this pending. Let's redefine this function. Okay. Let's say, let's redefine this whole function. Another method. I'm trying another method which is not there. So I'm going to redefine this function, and when mod x means cutting critical point is 0. So when x is less than 0, the function becomes 1 by minus x minus 3 is lesser than or equal to 1 by 2. For x is greater than or equal to 0, somewhere I have to include, no? So I'm including there. But I know from here the denominator can never be equal to 3. So x cannot be plus or minus 3. So I can never include plus 3 or minus 3 is something that I am noticing here. And then come back here. This is negative and this can also be positive. 1 by x minus 3 is also lesser than or equal to 1 by 2. Now I am going to adopt the same technique, minus x minus 3. When the reciprocal will become greater than or equal to 2. Or x minus 3 is going to become greater than or equal to 2. So minus x is greater than or equal to 5. So x is becoming lesser than or equal to, I'm multiplying both sides with negative sign. So a symbol has to change, lesser than or equal to minus 5. Here x is greater than or equal to 5. So I'm getting the same answer as this when I redefine. Correct? Okay, this is option number 2. But I still feel there's something wrong with what I have done. Let's see. So they have taken 1 by mod of x minus 3 is less than half means, this can have a lot of negative answers also. So many negative answers. So, and also decimal numbers. So let's consider that there are first, let's consider there are negative answers possible. So negative answers possible means denominator, denominator has to be lesser than the numerator. Greater than the numerator. Denominator has to be greater than the numerator, so that the answer will be fractions. Correct? One second. Mod of x minus 3 is lesser than 0. Okay, so if you want to get a negative answer, let's see another method where you want to get a negative answer. Because this can have negative answer. 1 by mod of x minus 3 is lesser than 1 by 2 means you can have minus 1 by 4, many minus 22. You can have many negative answers, correct? So for it to be negative, the denominator should be lesser than 0 because 1 is already positive. So denominator compulsorily for negative answers. Denominator has got to be negative, correct? Mod x minus 3 should be lesser than 0, not equal to 0 because denominator cannot be 0. So mod x has to be lesser than 3. So in this case you're getting less than 3 means x is less than 3 or greater than minus 3. So when you mark it in the number line, it's quite different to what you got here. Correct? You're getting differently. So this is one condition, case study 1, where I am thinking I can get negative answers. Case study 2, I can get positive answers, where denominator is positive for positive answer. But I have to get answers which is only less than 1 by 2, which means it has to be decimal number and it can't be greater than 1 by 2. It has to be decimal number. So I'm just thinking for it, the denominator has got to be positive, which means mod of x minus 3 has to be greater than 0. But I should also make sure that I am not getting answers greater than half. Correct? So fine, let's proceed with this. You know mod x is greater than 3. So x will be greater than 3 or lesser than minus 3. Okay, but in this case, for positive numbers, the denominator should not exceed 2. The denominator here got x is lying between minus 3 and plus 3. When x is lying between minus 3 and plus 3, all these are x values. None of this value should get you an answer which is greater than 2. The denominator should be only 2. If you put it is x is lesser than minus 3. X is already lesser than minus 3. X is already greater than plus 3. And the numbers that I plug in should not exceed a value which should not 2. If I put minus 4 plus 4 minus 3 is 1, it's exceeding. So I cannot include a minus 4. I cannot include a plus 4. Sorry, can I include a minus 5? If I include a minus 5, 5 minus 2, exactly I'm getting an answer. So starting itself is from minus 5 only. I cannot include any numbers between minus 3 and minus 5. Similarly, I can include numbers only from 5. Correct? Because even if I include a 4, minus 3 to plus 3. Okay, so you know that I cannot include a 4 or this. I can include only from 5 to, which is similar to this answer, 5 to infinity and minus infinity to minus 5, which is correct. However, what happens to these numbers, which is going to be between minus 3 and plus 3? Is there a graph between minus 3 and plus 3? X is here you have this condition, no? X is also lesser than 3. Yeah? X is also greater than minus 3. So x can also be here. And if you verify this, give one example. Let's say minus 2. Take that example, plug it in here. Minus 2 will become plus 2. And it's fine, right? So this is for considering that the entire answer can be negative. This is okay. So the answers can also be lie between minus 3 and plus 3, where you will get final negative answers, which is possible. You'll also get answers after 5 and before 5, which will all get you the second condition, where the denominator is always 2 or greater than 2. Greater than 2, not lesser than 2. It has to be 1 by 3, 1 by 4, 1 by 5. So then therefore, you're getting minus infinity to minus 5, minus 3 to plus 3, 5 to infinity. All of them is the answer. And you know 5 can be inclusive. 5 can be inclusive. Where is that? You already drawn with inclusive. So include it. Correct? And here anyway, you're getting minus 3 plus 3 not inclusive. So when you do minus 3 plus 3, it's not inclusive. And 5 to union of this, union of this. So such a difficult sum. When I do this sum normally, like my own way, I'm not able to think of that minus 3 and plus 3. These two ways that I tried is not getting me my complete answer. Do you see that? Oh my goodness. Oh my God. Anybody has a tendency to do like me only. Would you even imagine that this whole thing can be negative? So the condition for the answer to be negative, the denominator has to be negative. With that, you're finding the first answer. Then the whole thing can be positive, but there is a necessary condition. Denominator has to be greater than 2. Sorry, did I say less than 2? It has to be greater than 2 because it has to be lesser than 2, 1 by 4, 1 by 6, 1 by 8. So denominator has to be greater than 2. Such a way you have to mark it. Such a complicated sum. And you have to segregate it and do it, and this method in which I've done is completely irrelevant, and anybody will do it like this. And this can be definitely a JEE question where if you don't know to do this, you're gone. But not for a normal school exam. This question can be a JEE question, not otherwise. Superb. So let's go to next sum.
You need to call me whether she sends
Okay. Oh my God, such a complicated sum. It can be only a JEE sum. I don't think it can come for school exams. Okay, so let's go to next. 1 by mod of the ninth sum is mod of x plus 3 plus x by x plus 2 is greater than 1. Greater than 1, no equal to 1. Okay, so that's the question. So we now do this sum. And in the sum, we can take the 1 to the other side. Mod of x plus 3 plus